Now we're looking at the properties of the kite. Okay. Here was our kite, which we manipulated. We measured all the sides, and we found, to no surprise, that there were two sets of congruent adjacent sides. Okay. So, and that is by definition the property that we know belongs to a kite. Okay. And they are marked off. A, B, and B, C are congruent to themselves as indicated by the single tick mark. Double tick marks indicating that these lower sets of adjacent sides are congruent. Okay, so that is by definition that which applies to the kite. Okay, we then looked at the measure of the angles. Okay, and when we measured the angles, we find that we have, as indicated here, two congruent angles, and those congruent angles are the result of looking at the two triangles that are congruent here. Okay, so if we looked at the red and the green triangles, okay, we already know that they have equal sides at CB and AB, as well as AD and DC. And we also, if we drew this single diagonal, would certainly see that that's the same side. So those triangles, red and green, could be shown congruent by triple S. And of course, them being congruent by triple S would also indicate that we have opposite angles at A and C congruent. So we now pick up a couple other properties here, okay? When we look at drawing the single diagonal BD, we found that we had two congruent triangles formed, which is a property, and that as a result of those congruent triangles, corresponding parts of congruent triangles, CP, CTC, would indicate that angles A and C are equal. Okay? It would also indicate that the two angles up here at B and the two angles down here at D are likewise congruent. I think, as we showed, you could flip the green triangle into place, okay, into the red triangle, which would illustrate, okay, these angles up here at B, both equal, and the angles down here at D, both equal. So then that picks up another property for us. The longest diagonal bisects the opposite angles, okay? All right, so the longer diagonal bisects a pair of opposite angles is yet another property. When we drew the other diagonal, the shorter diagonal, AC, we found that they intersected perpendicularly, okay? That they were perpendicular, that a right angle was formed there, okay? So that they are perpendicular. We also found, when measuring the diagonals, the lengths of the diagonals from the vertex to their point of intersection, what we found was that CM and MA, as you can see down here, are always equal, okay, regardless of how I manipulate this. So then that leads yet to a final conclusion as a property of the kite, is that the longer diagonal splits the shorter diagonal in half, or more geometrically, we should say that the longest diagonal bisects the smallest diagonal. Okay, so as the properties pertaining to that of a kite, we have, again, in summary, okay, by definition, two sets of congruent adjacent sides. Okay, upon drawing the diagonal BD, we realized the property here, which I have labeled as property 3, doesn't really matter the order, that the longer diagonal splits the kite into two congruent triangles. With those congruent triangles, the green and the red as indicated here, by using corresponding parts of congruent triangles, we could show that there's a set of congruent angles at A and C, so one set of opposite congruent angles. We could also see that that diagonal BD bisected the angles here at B and D, leading to yet another property, okay? And upon drawing the shorter diagonal, we found that the shorter diagonal was cut in half by the longer diagonal, and that they met to form a right angles. So this is, in summary, all of our properties that belong to any kite, okay? These are the properties, 6 properties that you will need to remember, to which we will apply the algebra the next time around.